So this is a video about Intro to Polynomials. It should look like this. It is a handwritten assignment. I probably won't have handwritten ones nearly as often, but this is where we were at the beginning of this unit. You'll notice at the beginning it has some simplifying numerical expressions. Expressions are a useful thing to know. We're going to talk about that. Algebraic expressions. Adding binomials and simplifying. Adding and subtracting trinomials and simplifying. We'll talk about that. And then a couple bonus problems at the end. But we need to talk about a few things first, okay? So we're going to go through some of these terms. I'll zoom in a little bit so it's easier to see. And we're going to start actually with equation. Equation. Actually, no, we're going to start with expression. Math and expression is any make it red like the rest of the text. For some reason, it decided to be black. Expression in math, an expression is any number, variable, or combination of the two, including any operations. When we say operations, that's adding or subtracting. So what does that mean? Examples are, I'm going to make this further out too. Okay. Examples are, that's fun. Like, I don't say some expressions. You could say like 5. That's an expression. Or you could have like 3 times x. That's called a, well, numerical expressions only have numbers. Algebraic expressions have variables. That's the only thing you could have. 7x. Oh, yuck. Squared minus y. It can be literally any combination of those things. It doesn't really matter. Okay, so an expression is a very broad statement. You can have addition, subtraction, multiplication. Everything is an expression that you can write numbers and variables to represent something. Okay, it's called an expression. Expressions have variables. So that's an important thing. Now, what makes an equation different from an expression? An equation has an equal sign. This is when two math expressions have an equal sign between them. You cannot solve expressions, only equations. Okay. That's very important to know. So remember that. when we're solving things and finding out what x is and stuff, we always do that in equations. A lot of the things we'll deal with for a while will not be equations. So we won't be able to solve them. You won't say like x is 5. You won't say that. That's only in the equations. A polynomial a mathematical expression containing terms with plus and minus between them. So what is the examples of that? A polynomial is a very broad term. And just for the record, polynomial is what we call absolutely just about any number that you've dealt with so far in your life is also called a polynomial. Okay, so you could have like examples are 2x plus 5y minus 17. Or 15 minus 7x. Or you could have, I don't know, 125x y minus 15z plus 5y minus x. And you could do this for a long time. All right, a term. These are the parts of a polynomial. They contain multiplication, division, but are separated by a plus or minus sign. Right? So that's what terms are. Efficient. Look at all this information you have. Okay, so this is so that you can have it. You need to have it if you're having troubles. These are the number part of any algebraic they count how many times that variable they count how many times they count it. How many of a variable there, let's say. An example of that is the weird one. It's going to be 5x. 5 is the coefficient of x. It is saying there are 5 x's. All right, So that's what coefficients are. Mostly this is just to get some of these words down, just in case we use them later, okay? So you can write this down someplace. You can screenshot it and save it for later. Monomial is a polynomial with only one term, like 15 or 27xy. A binomial, you might guess mono means one, bi means two. In a binomial, you have two terms. It's a polynomial with exactly two terms, like 27 xy plus 15 or 5x minus 7. So y, I don't know. Line, almost there. A trinomial. A polynomial. You guessed it, exactly 3 terms. 3x plus y minus 13. Trinomial. Okay. To simplify, we cannot solve a polynomial because it is an expression, not an equation. Remember, in equations, we add or subtract or multiply from both sides. But if we write it its simplest form with as few terms as possible, that is called simplifying the polynomial. It's 10 o'clock. All right. With as few terms as possible, we call that simplifying the polynomial. Simplifying usually includes getting rid of parentheses and adding like terms. And that's our last thing. We're going to talk about what are like terms. These are terms in a polynomial that have exactly the same variables to the same powers. If like terms can be added to one another to find the total number of that variable or variables. So what terms are? We'll talk about that a little bit more. I'll give you an example, but I think we should get to the actual assignment. So everything in here is some form of polynomial. So our first one is a numerical expression. Technically it has 1, 2, 3, 4, 5, 6, 7, 8 terms, and they are what we would call like terms. They have the same variables because they literally don't have variables, so that's the same. If they had variables and they were all the same, you'd have them exactly like we're going to do right now. But one thing we have to get used to is thinking about addition and subtraction. Instead, we're going to think about it as putting numbers together, and some are positive and some are negative. So what does that look like? Well, so for example, these are all my positive numbers, and these are my negative numbers. If I add my positive numbers, my purple numbers, I get 1 plus 2 is 3 plus 4 is 7 plus 6 is 13 plus 8 is 21. And then when I add my negative numbers, I get negative 3, that's negative 5, makes negative 8, and 7 is negative 15. So really, this is 21 minus 15. All I did was I combined the negative numbers and the positive numbers beforehand, and now it's much easier to add these. It's very important to think about these things as positive and negative numbers. I can tell this is negative because it's got a minus in front of it. That is going to be very useful in the future. Okay, so now I know 21 minus 15. Well, that is just 6. This is a good example of me showing my work. It says to show your work. Please don't just write 6. You can do something to show how you got it. You can square some of them. You can put squares around these guys and circles around those or something if you're doing it by hand. There are lots of ways to do it, but if you're on Kami, you can color code it. So this one right here, I could do this any number of ways. I could take a look at these ones. I could ask myself 87 and 93. Let's see, that's just 6 more, right? From 87 up to 93, so that's just going to be 6. When I subtract 87 from 93, when I put negative 87 together with 93, I get 6. If I look at 26 and 34, that's going to be 8. Negative 8. Because 26, from 26 up to 34, that's 8 more. Yeah. And then I got 15. Well, that's a lot easier, right? 20 is 15 minus 8 is actually 7. So you can see I can add these in ways to where it's not the most complicated thing. And that is what we're shooting for. I'm going to stop for a second. All right, and continuing along, we get to question number 3. Think about how you would do this. Just take a moment and figure out how would you do this. What are the easiest things to put together? You know, do I want to put the positives together and the negatives? What do I want to do? I might like certain numbers adding to 10. So I could go like, well, I don't know. I could say these make 3. This and that makes 10. This and that also makes 10. Let's see. 3, 10, 10. I'm going to take out the negative 5. Let's do negative 5 right here. I've got everything accounted for, negative 8. Now let's do 9 minus 10 is negative 1. So now this is simpler. I got 3, 10, 10, minus 5. We'll put these guys together because why not? 13. 10 minus 5 is 5. Minus 9. That's 18. Minus 9. Once you get the hang of handling these numbers, it doesn't matter the way you do it. It's just a matter of keeping track of things and not trying to do too much in your brain. Because if you try to do this in your brain, you will likely forget a number. I made sure that I got the 1 and the 2 here, the 3 and the 7, they're taken care of, the 4 and the 6 makes 10, -5. All right, now I got to get to the 8, the 9 and the 10 are taken care of. I accounted for all of the numbers every step of the way. And that is what we have to remember. I'll put that there too, okay? So do you have to make all of these brackets later on in math? Absolutely not, but we're gonna get better at it. Okay, so now I've added numbers in all sorts of orders. That's great, okay? I showed you, you can color code it. You can also make these brackets if that helps you. There are lots of ways to keep track of your work. Now, when we talk algebraic expressions, now we've got x's and y's in there. The nice thing about algebraic expressions is they make it even simpler for us to know what we can put together, because the rule with algebraic expressions is I can only add like terms. And we said like terms, well, let me go back to the end here. So a good example of like terms, let's do some examples. Adding like terms is one of the most important things we'll learn right now, okay? So we said like terms have exactly the same variable to the same powers. Like terms can be added to one another. So I could have 3x plus 5x, and I can add them together to make 8x. I have 3 x's and 5 more x's for a total of 8 x's. That's allowed. I could also do 6y plus 8y equals 14y. But 3x plus 6y cannot be added because they, because the terms are not like terms. That's why. So let's apply that to here. What are the like terms? Well, all I have to do is keep track of them. It's actually not too bad. We have 1, -3, and -5 are all numbers. When I put those together, I get -7. All right, now if I do 2, 4, and 6, when I put all of those together, I get 12 x's. 2 x's plus 4 more x's plus 6 x's is a total of 12 x's. I have to put a plus in front of there. This right here is the solution. This is what we would call a binomial. We started with 1, 2, 3, 4, 5, 6 parts. We don't have a term, we don't have names for anything above a trinomial. We just call them all polynomials after that. But when you only have 2 terms, it's very common to just call that a binomial because it has 2 terms. One term is -7, the other is 12x. So now I have 1, 2, 3, 4, 5, 6 terms again. Some of them have x's and others have y's. That's important to note. I cannot add x's with y's. So my x's are -3, 15, and 2, the coefficients of x. And I can add those together. 2 plus 15 is 17. Minus 3 is 14x. And then I'm going to go ahead and I'm going to say, okay, but I also have 3y's, minus 5y's, and 20y's. 20y's minus 5 is 15, plus 3 is 18. So I should end up with 18y's. Notice I have to put a plus between them. I put a plus between them. You always put a plus between them because that's what keeps them separate. Otherwise, they're just 2 random numbers. I still have to add them. I just can't until I know what x and y are. A good way to think about this is x could be like dogs and y could be cats. 14 dogs plus 18 cats does not make like, what, 32 dog cats, or 32 dogs, or 32 cats. No, they're just separate things. So the variables are different things, so I can't count them together. That's all. That's really all that's going on here. All right, 14x's and 18y's. That's as far as I can go. I cannot add them. Okay, the next cool trick we have, and I'm going to type this right above, if a parentheses are preceded by a plus sign, then they can just be ignored. That's important. No number. Plus sign and no number. Okay? So these plus signs, usually when you have parentheses, you have to add inside of them or something like that. But I can't add two x's and a 1. They're not like terms. So what am I going to do? Well, if there was a 2 here, I would have to distribute it. That's another thing that parentheses do. But there's no 2 there. There's no number here. Just a plus sign. In that case, the parentheses do nothing. The parentheses don't do anything. So I can ignore them. I can just redo this whole thing. Say, okay, so this is just 15 plus 2x plus 1 plus 5x minus 10 plus, and that one also does not have anything in front of the parentheses, so I'm just going to leave it 3x minus 5. And there we go. That's it. Now here I'm going to do it a different way this time. Let's realign these numbers on our own. We're going to put the x's first. I'm going to say 2x's. That's the first one. 5x's. And 3x's. So I got all of the x's. This might be a way that you'd prefer to do it. So I got rid of the 2x, the 5x, and the 3x. I'm going to type in the next numbers. 15, 1, negative 10, and negative 5. Okay. Well, notice that means I end up with, I'm going to go to this now. I'm going to write the rest. I have 2x's, 5x's, and 3x's. That's a total of 10x's. And then I have 15. This is another 15, isn't it? 15 minus 15, and there's just 1 left. 1. And it's a positive 1. So that's my answer. 10x plus 1. Easy, right? Yeah, really easy. Okay, this one. Think about how you would solve it. Give it a thought. This one's scary. Has lots of variables, but the truth of the matter is that simplifies everything. Because I cannot add x's with y's or z's with x's or z's with y's. I can only add things with things that are like them. So let's do a lot of numbers, of colors. 2x and 5x, those are the only x's. That makes 7 x's total. Okay, next I'm going to notice this parenthesis has nothing in front of it, just a plus, so I can ignore that parenthesis. Oops, I don't want to make that purple. I want to make the next circles purple. Now I'm going to circle the y's. 3 y's, that's a z. That's an xy. That's not the same thing. And 10 more y's. 3 y's plus 10 y's is a total of 13 y's. Going back to this, let's go with red for the z's. 2 z's minus 5 z's. 2 minus 5, okay? Well, 2 minus 5 is negative 3 z. And finally, we have xy's. Let's do some xy's. We'll make that one green. Negative 100 xy's and positive 50 xy's. Well, that's 50 minus 100. Well, that makes negative 50. So I end up with negative 50 xy. And that right there is our answer. Boom. Boom. Done. So it's all a matter of just keeping track of what can be added. And the truth of the matter is you just have to look at the variables, make sure the variables are the same. Notice x's can only be added with exactly the same thing as them. Even xy's. Even though there's an x in here, that's different from just an x. That's an xy. It's a different variable. Okay, or different algebraic term or whatever. They're not like terms. Okay, so now we learned what happens if you have a plus in the front of something. Another way we can think about this is we have to distribute whatever's in front of here. We have to multiply it by everything inside. So if I multiply 10 times positive 1 and negative 2 times positive 1, well, positive 1 doesn't do anything. So just like I said, when I multiply these out, I end up with, well, a very boring answer. 3x plus 5 plus x minus 2. All that happened was I got rid of the parentheses. That's it. If I go over here, I have to do the same thing on the other with when there's a negative. And this is where things change. Negative 1. If I distribute things, it changes the sign of everything. Okay? So this is one way to think about it. I'm going to talk about another way in a sec. So if I go back to the text here, I end up with 3x. Front doesn't change. Negatives only apply to what they're in front of, to the left of. So negative 1 times 10 is negative 10x. And negative 2 times negative 1 is positive 2. So it changed the sign. Notice, they're really the same thing. The minus changes both the 10 and the 2. The minus will change everything in here. So another way you can think about it is I'm subtracting the thing inside. Oops. The thing inside the parentheses here. So I'm subtracting 10x and I'm subtracting negative 2. And subtracting a negative is adding. So that's another way you can think about it. All right. So what is the answer here? I'm just going to tell you the answers for these ones. 3 plus 10 is 13. 5 minus 2 is 3. Done. I expect you to do this step here, but I'm not going to fill it in for the next one. So you're going to have to do that on your own. I'm just going to tell you the answer. 3 minus 10 is negative 7. 5 plus 2 is 7. There's an answer. This one, these are going to be fine. I'm going to have this 4, so it's 1y left over, and 10 plus 5 is 15. Please fill in this chunk the same. I just don't want to take the time because I'm doing notes for you out of the goodness of my heart. 4 minus a negative is actually plus. That's going to make 7y. In fact, you should be solving these on your own and then just double checking. 10 minus 5 is 5. 15. Let's see. Negative 2x plus 15 is 13x. 15 minus 2 is 13. $15x minus negative 2x is plus, so that's 17x. Negative 2 minus 15 is negative 17. All right, now we're going to do the same thing with trinomials. Another thing, x to the second power and x can't be added. You can only add x to the second power with x to the second power. So notice this has a plus, so I don't need to worry about the parentheses at all. I can just say, well, I'm not going to type this because I don't really like typing squares. X squared plus 5x minus 10 plus 2x squared minus 10x plus 20. Okay, so what am I going to do here? Well, I just need to make sure that I'm going to circle things. No, I don't want to do that. I want to do this. I'm going to circle the x squareds. There's 1x squared and 2 more x squareds for a total of 3x squareds. And then I'm going to go over and I'm going to look at what about the x's. Well, I have 5x's minus 10x's for a total of negative 5x's. And then I'm going to take a look at the non-variable numbers, the constants. 20 and negative 10 as to make positive 10. Remember that right there, my friend, is the answer. But watch out for negatives. If I have a negative, I have to distribute everything. Try to solve this one on your own and pause it and see if you get the right answer. And here's the right answer. The answer is going to be 10 minus 5 is 5x squared. 20 minus negative 50 is actually 20 plus 50, so that's 30. And 35 minus 15 is 20. You can see once you get the hang of this, it's actually really fast. Okay, we're almost through. 45, this is a plus, so that means that the parentheses are not going to do anything. So I'm going to end up with, try it on your own. And here's the answer. 45 minus 3 is 42x squared plus 5x. I'm adding 15 x's with negative 10 x's. That's 15 minus 10 is negative 5. And 100 minus 50 is 50. And that, my friend, is the answer. After this assignment, you will be allowed to just write things like this. Where actually the next assignment, I'll want you to do that really fast. So let's try this. 45x squared. Let's see, minus negative 3. Minus negative 3, that's plus. So that's 48. X squared. 15 minus negative 10 is 15 plus 10, that's 25. X. And 100 minus negative 50 is actually 100 plus 50, so that's 150. And there you go. That's the answer. So notice sometimes they subtract, sometimes they add. Okay, now this one. What's the perimeter of the rectangle? This is one we're going to talk about in class. So this is my length of my rectangle. And that's my width of my rectangle, right? Well, this is also the same length as that. And this is also the same length as that. And if you remember, perimeters are just when we add all the sides up. So I'm going to put 2 of this and 2 of that. I'm going to be very fancy. I'm going to write 2 of the height of this rectangle, which is going to be 15x plus 30. So now I have 2 of my sides. And then I'm going to go ahead and I'm going to also say I need to add that to 2 of the top, which would be the top and the bottom, right? 2 times 25x squared plus 10x minus 15. All right, it's going to be 30 x's plus 60 plus 50x squared. So it's 50. 50 x squared plus 20x's minus 30. Now I have to add like terms. The 50x squared is all by itself. The 30x's and the 20x's also makes 50. But I cannot add it with the x squareds because x squareds and x's are not the same thing, even though the first number is the same. You could do a really interesting factoring thing with that, but we're not doing that right now. 60 and negative 30 makes 30. My handwriting is terrible, but hopefully you get 50x squared, 50x, and 30. Now this one's a little tricky. What we're looking for here is adding in a different order to help. Now I could add 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. I could type it onto a calculator, but hopefully you don't make a mistake because it could take a while just to type it in. Or I can kind of think outside the box and I can try to find things that are nice to add to. And this has a lot of pairs of numbers that add up to 500. So if I add 5 and 495, 4, 496, 3, 497, 2, 498, 1, 499, they all make 500. So the question really is, how many 500s can I make? Well, I'm going to keep on going until I get to, let's see, 250 is in the middle, right? Between 1 and 499, it's in the middle. I could do 249. And 251, and guess what those are going to make? 500, right? So I'm going to have from all the way up to 249. Each of those will make 500. So that's 249 500s. And that gets rid of all of these numbers and all of those numbers. The only number that's left over is the 250 in the middle. Because I have each 1 and 499 makes 500. 2 and this makes 500. 3 and that makes 500. I continue that 249 times. But I still need the 250 that's stuck in the middle. I'm talking through this really fast because I'm in a hurry, but I'll be happy. We're going to go over it in class too. So I'm going to type that in my calculator because I'd rather not give you the wrong answer. 249 times 500 plus 250 is, when I add all of those numbers up, I get 124,750. That's the answer again. Okay, so I did this. Gives me this answer. Last question, right? Two trinomials that have a variable x squared in them. When they subtract, they make something. So I need x squareds. We'll say 3x squared plus 5x plus 30. I'm just going to write that one down as my first one. And now I'm going to try to figure out what do I need to subtract from that to get this guy, 5x plus 10. Well, I need to get rid of all the x squareds, right? So that's going to mean I need to get rid of 3x squareds. What else do I need to do? Well, I don't need to get rid of the 5x. It's already there, isn't it? Okay. And then 30 minus 1 makes 10. Oh, that's going to be 20, but I'm already subtracting. So this is an example of what you could write. This minus that make 5x plus 10. Okay, because these guys are going to cancel out to make 0. There won't be any x squareds. 5x minus nothing stays 5x. 30 minus 20 makes 10. There we go. All right, so those are your answers if you want to do it exactly like me. But remember, these notes are also useful for the future. All right, good luck.